Hello, math students. Mr. Ray here. We're going to continue on with our unit on quadratic expressions. This is the third lesson in our unit. The first two lessons were teaching us how to, first of all, how do you multiply two binomials together? And you learned about, there's a couple of ways of doing that using this acronym called FOIL to remind you that there's 4 multiplications to do. The other method was called matrix, and it basically involves setting up a little table, breaking out the two terms on the top and on the side, and then multiplying in each box, and then combining all the terms. And then the second lesson was the special cases of, well, what if the two binomials are the same binomial? What would that result look like when you multiply them? And secondly, what if the two binomials were close to being the same, but we switched the sign in between the terms, one being positive, one being negative. So what we're going to start off with today, so this is kind of the beginning of the main part of this unit. So we're going to look at the first type of factoring, and it's called common factors. So the type of factoring is called common factoring, and this will be an extremely important type of factoring. We're going to learn 3 other types of factoring after this, and then we're going to kind of put it all together, and basically you'll become factoring experts, hopefully. Okay, so what is this factoring? Well, it's actually the opposite of expanding. So if you kind of read this backwards, if you started with x times x plus 3 and you expanded it, you would get x squared plus 3x. So you know how to do that from previous grades. What we're learning today is taking the expanded version of this polynomial and creating factors. A common factor in this case. So basically in this example, there's an x that's common to both terms, so we kind of factor it out. You can see once we find the x, it's a matter of figuring out, well, what do these two terms have to be? So we'll be looking at several examples of that. I'm going to leave this for now and come back to it as we encounter the situations. Maybe review this at the end. So the first thing we always do when we're common factoring is first find, is there a common factor? And we want to take the biggest possible common factor out. And what I mean by that, I'll show you here. So in this case, for these examples on this lesson, I'm actually going to write out the greatest common factor, and that stands, GCF is the short form for greatest common factor. So that's your first step for each of these. So you ask yourself, what's the biggest term that I could divide evenly into both of these terms, 6x and 3, positive 3? Now in this case, since there's numbers and variables, we're going to break it apart. First I'm going to look at the number part, the constants. So I have a 6 and a 3. What's the biggest number that can go into 6 and 3? Well, that would be a 3. The 3 is the biggest number that can divide evenly into both. So that's going to be part of my greatest common factor. And then you look at the variables. So in this case, the only variable that's being used is x. Now, in order for x to be a common factor, it would have to be in both terms. And you can see that in this case, it isn't. So I cannot have an x in my greatest common factor because all the terms don't all have an x. So that is the extent of my greatest common factor. So now we use that. So in the next line, I'm going to start off with my greatest common factor, and then I'm going to put a set of brackets and leave room for 2 terms. Okay, and it's going to be 2 terms because we started off with 2 terms. So if I'm going to multiply this with something inside here, it has to be 2 terms that will create those 2 terms in the result, or at least in the starting expression. Okay, so now I'll explain a couple ways of doing this. Basically, one way to look at this is say, okay, what do I have to multiply 3 by? So I'll put little placeholders here. So this term here will be what do I need to multiply 3 by to get 6x? So you could just kind of think backwards. Well, I'd have to multiply it by 2 to get the 6, and I'd have to multiply also by x to get the x. Okay, and then the second one, what do I have to multiply 3 by to get 3? Well, that's straightforward. That's just 1. It's going to be plus 1 because I'm not changing the sign, and that's your answer. And you can always check your work when you do any type of factoring. So if we expand this out, we should get back the beginning expression. So just try it out. 3 times 2x, that would be 6x. 3 times positive 1 is positive 3. Good. The other way to think about when we're trying to get these terms in the brackets is actually divide each of these terms by the greatest common factor. So for example, 6x divided by 3 would be 2x, and 3 divided by 3 would be positive 1. Okay, so whichever way works best for your common sense, use that method. So some people like to think of it as find the mysterious number that you multiply with 3 to get that, and some people would rather say, okay, what's 6x divided by 3? It's really the same thing, you're just doing kind of opposite approaches. Okay, let's try the second one. So if I'm looking for a greatest common factor there, first thing I look at the number parts. So I have an 8 and a 7 or negative 7. What's the greatest common factor there? Well, they actually have nothing. I can't divide. The only thing I can divide evenly in there is 1, which doesn't really count because that's true for any numbers. I can't divide these by 2, 3, 4, 5, 6, 7. Okay, so basically there's no number part. Okay, so I'll just leave that empty. You don't put 0. You just leave it blank because there's no component that's the number. So the next part, you look at the variables. So I have an x that I'm using. So the first thing I look for, is there an x in every term? Yes, there's an x squared here, and there's an x there. So right away I can put an x. Now, you're not quite done yet because it could be various powers of this. Is it just x, or is it x squared, or is it x cubed? So here's how you do that. Now, when I see that 7x, that's really 7x to the 1. Right? We just don't write it. When I know I have an x that's common to all the terms, what I do at this point is just pick the lowest exponent. So in this case, I have an exponent 2, exponent 1. So my greatest common factor is the 1, which I could put a 1 there, but I'm not going to. That's x to the 1 is really just x. So in this case, that's the greatest common factor is just x. So I go use this on my next line. So I'm rewriting this as in factored form. So I've got my x on the outside to the left, and then I've got my 2 terms that will go here. So basically what I'm doing, I have to figure out these 2 terms that when I multiply each of them with x, I get back to this. Okay. So again, your choice as to how you do this. Maybe this one I'll do the division where you say I'm going to divide each of these 2 terms by x to create these 2 terms. So 8x squared divided by x. So that's going to be an 8. And I'm going to need have 1 x left over, x squared divided by x. If you remember your exponent math, when you divide, you subtract the exponent. So that would be 2 minus 1 would be the new exponent. And then here, negative 7x divided by x, well, the x's just cancel. So you have 8x minus 7. Or we could have done it, what do I need to multiply x by to get 8x squared? Well, I need an 8, and I need 1 more x, so that's 8x. And over here for the second one, what do I have to multiply x by to get negative 7x? That's negative 7. Okay, and again, you can always check your work by expanding your factors to make sure you get back to the original expression, x times 8x squared, sorry, x times 8x is 8x squared, x times negative 7 is negative 7x. So there's no excuse for hoping that you get a factoring question right, because you can always check, okay? There's no excuse for having to hope that you're right. You'll know if you're right or wrong because, you know, your check will either work or it doesn't. Okay, next question here. This time we've got the variable k. You know, we could use any variable we want. So let's change it up here. So first thing I do is look at the numbers of each of the terms. What's the biggest number that goes into 25 and 15 evenly? Well, that would be a 5, right? Nothing higher than that. So you always pick the highest one. So that, for this case, it's going to be 5. And then you look at the variables. So in this case, we're using the variable k. And yes, I do have a k in each. So at the minimum, that will work. Now we have to find the highest exponent that will work. And again, use that rule about looking at the exponents of all the k variables. In this case, I have a 6 and a 4. We picked the lowest of the two, so that's going to be a 4. So now we know the greatest common factor. We write that out front. We put our brackets in with room for 2, and it depends on how many terms you have here, right? So if I'm common factoring 2 terms, I'm going to have 2 terms in here. If I had 4 terms here, I would have 4 terms in here because I'm creating 4 terms. So I have to start with something in the brackets that has the same number of terms as what we're trying to create here. Okay, so I'm looking at 25k to the 6th. How do I create that from 5k to the 4th? So let's look at the number part. So in order to get a 25 from 5, that means I have to multiply first by 5. That 5 times 5 gives me 25. And then k to the 4th times something gives me k to the 6th. Well, I need to multiply by k 2 more times because I've already got 4, but I need 6. So that's going to be k squared. And you can check here. 5k to the 4th times 5k squared, that would be 25. And then k to the 6th, remember we add the exponents, not multiply. So that would be 25k to the 6th. So far so good. And then the second term, what do I have to multiply 5 by to get 15? That would be plus 3. And what do I have to multiply k to the 4th to get k to the 4th? I don't have to multiply by anything. Well, you could say 1, but no more k's are needed. I have all I need. So the common factor, the term here needs to be a 3, and you can check that by multiplying these two through the brackets. 5k to the 4th times 3 would be 15k to the 4th. Okay, so hopefully this is making sense. Now we have something here that's interesting. We've actually got multiple variables. So if we try to create a greatest common factor, first of all, we look at the number parts. So a 5 and a 7. Is there any number that can divide evenly into both of those? No, there's not, except for 1, but 1 doesn't count. So I don't have a number part for my greatest common factor. And then you'll notice I've actually got 4 different variables. I've got an x, a y, a w, and a z. So I look at each one separately. So I look at the x. Now in order for x to be a common factor, a greatest common part of the greatest common factor, it has to be in all the terms. So in this case we've got 2 terms. So I need to have an x here and x here. I don't. Okay, look at the y's. I don't have y's in both terms. So x and y aren't part of the greatest common factor. Same thing with w and z. I've only got them over here, not there. So what happens in this case? Well, in this case there's no greatest common factor, or there's none. So we can't actually factor this one. So we'll say not factorable. Now, anytime I give you a question, well, mostly on the homework, for sure on the tests, you'll almost never see this, okay? This is an important question because it starts to look like, well, everything has a common factor, but you can see that that's clearly not the case. You could easily pick two terms that have nothing in common with each other, and there would therefore be no greatest common factor. So for the point of showing that, we got this example here, but when you're doing tests and most of the homework, you'll see that pretty much, I would say 98% of the questions do have a common factor. Okay. All right, next page. So we got a part C here, sorry, part E. So in this case, greatest common factor. This one's a little trickier. This time I have 3 terms. Okay. So I look at the numerical parts. I've got a 21, a 28, and a 7. So you have to think, well, what's the biggest number that can go evenly into all 3? And this is where it really pays off to be good with your mental math. Hopefully you can see that a 7 goes into each of these. And since 7 is the lowest of the 3 numbers, it definitely can't be higher than 7. So that's a good starting point. If you're not sure, you know, where should I start guessing for the numerical part, it could never be higher than the lowest of the numbers that you're looking at. So it's, you know, since 7 does go in evenly, that definitely is the highest or the greatest highest number that you could use. Okay, and now we look at the variables. So you can see here I've got variable C's and variable D's. So I'm looking at each one separately. Go through, first do the numbers, and then look at each variable separately. It saves a lot of frustration and guessing if you do it in that order. So I'm looking for C's. So the first thing I check, does every term have a C? Yes, it does. So it definitely has a C. Now the question is, what's the exponent that goes with the C? This is where you check your exponents of the C's in the terms. So I have a 4, a 2, and a 1. Okay, so the 1 is the lowest, so that would be a 1, or just leave it like as a C. Okay, now we go to the D's. So does every term have a D? Yes, it does. Yes, they do. So there's a D there as well. Now, what's the lowest of the exponents of the D's? I have a 3, I have a 5, and I have a 3. So the lowest is 3. So that would mean D cubed. I could divide every one of these terms by D cubed. Okay, so that's a little trickier than the other ones. So now that I've got my greatest common factor, I can write that out front. Now, inside the brackets, remember I told you, you have to leave enough room for the same number of terms that were in the question. So I'm actually going to have 3 terms here. Okay, and now we'll do the, you know, what do I have to multiply 7cd cubed to get 21c to the 4d cubed? So take your time on this, break it into parts. What do I have to multiply 7 by to get 21? That would be a 3. What do I have to multiply c by to get c to the 4th? Well, that's another 3 c's that have to be multiplied. So that would be c cubed. And I have a d cubed, and I want to create a d cubed. So you don't put another d here because that would be wrong. That would give us d to the 4th. So if the exponent matches what we want it to become, then you just leave it. That's really just multiplying by 1, which is already in here sort of, but definitely no more d's are required. Now we go to the second term in the question. What do we have to multiply 7 by to get negative 28? Make sure you put the negative with the number. Well, that would be a negative 4. Okay, and you can always check it. What do I have to multiply c by to get c squared? Well, that would be 1 more c. Would I have to multiply d cubed to get d to the 5? So that's 2 more d's I need, so that would be d squared. Now this one's an interesting one. You'll see in a second. What do I multiply c by to get, what do I multiply 7 by to get 7? Nothing, it's already done. What do I have to multiply c by to get c? Same thing. It's already there. What do I have to multiply d by to get d cubed to get d cubed. It's already done. So sometimes students will get tempted to say, I don't have to do anything when I multiply this to get that because it's the same thing. So students sometimes feel like, oh, there's nothing there, I put a plus 0. But if you did that, I'll just shade it in there. If you put a plus 0 and you multiplied 0 with 7cd cubed, you get 0. So you wouldn't actually create this if you put a 0 here. So if the term that you're trying to create is the same as the greatest common factor, you have to multiply by 1. That gives you back what you started with. Okay, you're not changing it, but you'll have a term that looks exactly like that. Okay, so there's lots of examples of doing this in the homework, but again, I would just say be patient when you're creating your greatest common factor. Look at the number part first, find the biggest number that goes into all the number parts, then look at each variable. In order for a variable to be in the greatest common factor, it has to be in all of the terms of the question. And then it's just a matter of figuring out what's the degree. Okay, and then once you've got your degree, you methodically go through each term and check what number do I have to multiply greatest common factor by to get the term I want, and look at each of the variables and say what do I have to multiply that variable by to get our target term here, and then just do that for each term and it should work out. So make sure you practice that. It's easy to look at somebody doing it and say that makes sense, but you'll only be able to do it if you practice yourself. Okay, now if you notice, if I go back, every time we've done greatest common factors, see the greatest common factors, 3x, 5k to the fourth, 7cd cubed. These are all monomials. So you remember monomials are basically one term. So it is possible to have a binomial common factor. And these are a little tricky at first to wrap your head around. So I'm going to show you a couple ways to think about this. And I'll just go back. So I'm going to do kind of two approaches. I'll do the first one over here, and then what I want you to do when you see these right below it. When you look at this, it looks a little confusing because, it doesn't look the same. These aren't real terms because you got brackets here. Okay, so if you notice in the brackets, you got y plus 1 a couple of times. So I'm going to show you a method here. It's called the substitution method, and you end up using it a lot, especially in grade 12. But it helps to simplify the question. So I'm going to actually let this y plus 1 be represented by another variable. And you might think, well, that's just going to make it more confusing. But I'm going to pick the variable a, and I'm going to say let a equal the y plus 1. I got brackets around there, you don't have to. So if I was to now update this equation, this expression, not equation, everywhere I see a y plus 1, I'm changing it to a. So this now turns into 3xa plus 7za. And now, if I asked you to common factor this, you could, okay, because the brackets are gone. So if you look at this, with the 3 and the 7, there's nothing common there that I could factor out. X I can't factor out, Z I can't factor out because it's not in both, but the A is common in both. Okay, so the greatest common factor is just A. So when I factor that out, okay, it's what do I have to multiply A by to get 3xa? Well, that would be 3x. A times 3x gives me 3xa. What do I have to multiply what do I have to multiply A by to get 7za? Well, that's just plus 7z. Okay, and that, you might think you're done, but remember, we did this substitution up here. So what I need to do to get back to the original question is to change the a back to y plus 1 and leave the second one as it was. And now we're done. That's the actual answer. Okay, so here's what you have to do for these binomial factors. So you almost have to think of, what do we have in common in these two things? Well, we have the y plus 1. The y plus 1 is multiplying within both of these so-called terms. So that's actually a common factor. It's a common binomial factor because it's got two terms as the factor, which is kind of new. So what I'd like you to do, I mean, you can always do this if you want, but after a while you'll start to see, oh, the y plus 1 is common to both. So I'm actually going to factor that out as something that they both have in common. And then you say, well, what do I have to multiply y plus 1 by to get this? Well, that's pretty self-explanatory. We're multiplying it by 3x. Okay, and for this one, what do we have to multiply y plus 1 by to get 7z times y plus 1? Well, that's the 7z. So this is the quick way of doing it, is recognizing that y plus 1 is a common binomial factor. So we're going to actually factor that out first. That's our greatest common factor, even though I didn't write it down as that. And then what do we have to multiply this by to get the original? Well, it's what each of the multipliers are in front of the common factor become the second factor itself. And you can always double check this by doing a FOIL and seeing that it does work. You can see that we did get the same result there and there. So let's do the same approach. We'll do the substitution method for this one as well. You can see similar thing going on here. We've got an x minus 3 that seems to be a common factor in both of these expressions there. So I'm going to do a substitution, let a equal x minus 3, and then we're going to update this by replacing x minus 3 with the a. So now I'm going to have, that's going to be equal to 2x times a, 2xa, minus 5 times, replace the x minus 3 with an a, so that's minus 5a. Okay, and when we do our common factoring here, you can see the same thing. A was our greatest common factor. The numbers 2 and 5 have nothing we can common factor. So if I figure out what I have to multiply a by to get 2xa, that would be 2x. What I have to multiply a by to get negative 5a, that would be negative 5. And then finally we just change the a back to what it really is. It's the x minus 3. So I have x minus 3 times 2x minus 5. Okay, so you can do it that way. After you've done it, 2 or 3 times like this, you start saying, well, I didn't really have to do this. I can now recognize. So if I go back, I can see, oh, I've got an x minus 3 that's a common factor to both of these. So I'm going to factor that out. Common factor it out. And what do I have left over? Well, I have the 2x for that one, and I have a minus 5 for that. So you notice we got the exact same answer, either directly doing it or doing it through substitution. Okay. All right, so this is a little bit tricky at first, but you're going to need to know this method for a lesson we're doing 2 lessons from now, where you see something written like this and you need to take out the common binomial factor. So it's definitely a skill you need to have. Okay. Now this question here is actually, it's a different method of factoring. It's got its own method, so it's really not common factoring. There is a little bit of common factoring in it, but this we call this factor by grouping. And the whole thing we do here, like if I just told you to factor this using common factoring, you'd probably look at this and go, okay, that's got an A, that's got an A, those don't. X here, no X, X. So X isn't common, A is not common, Y is not common, and the two are common to there but not there. So there's really nothing that all three of them have in common. So you'd think, well, there's nothing I can do here. But there's actually a method called factor by grouping. So what we're going to do here is we're going to group. So we're going to take the first two terms, put them in some brackets. So I have AX plus AY, put in brackets, and then whatever sign's in front of that third term goes between two sets of brackets. Very important, because you're not multiplying these two things, you're adding the two sets of brackets, and then the third and fourth terms go inside the second pair of brackets. Okay, so all I've really done is put brackets around first and second, and third and fourth. It gets a little trickier when you have a minus sign in front of there, because you end up having to switch the sign of the fourth term. So we'll see that in a couple lessons from now. All right, so I've got this written as basically, it looks like two binomials that are being added together. Now the factor by grouping basically says, okay, instead of trying to common factor all four at once, because it doesn't work, we'll break them into two groups and then try to factor each group. So if you looked at these two terms, what do they have in common? They have the A. So I can factor an A out from these two terms. When I do that, the second factor will be x plus y. You can check that. AX plus AY, okay? And then we do the second group. What do these two have in common? They have the number 2. So 2 would be the common factor there. What's left over? X plus y. Okay, so you're thinking, okay, well, where did that get me? If you look at these two sets of brackets, they have the exact same binomial, which is x plus y. So now this basically brings us to the previous question with the binomial factor. Okay, so now I'm saying to myself, oh, that's common to both, the x plus y. Right, and if I factor that out, if I remove it, what's left over? A plus 2, so that's my second factor. Okay, and that's how you do that. So here's another example. We have 9x squared plus 15x plus 3x plus 5. You notice when we do factor by grouping, you have to have exactly 4 terms, because you're basically taking 4 terms and grouping them into 2 brackets of 2 terms. Okay, so that's a prerequisite for this method. So if I'm going to group these, it means putting brackets around the first two, 9x squared plus 15x, bracket, and then we put the sign that's a plus 3x, so I put a plus between these two sets of brackets, and then 3x plus 5 goes here. Okay. Now again, just like we did up here, we're going to take each group and find a common factor for just those two, and then try to do it over here. So I have 9x squared plus 15x. I look at the numbers, 9 and 15. What's the biggest number that goes into both? Looks like 3. So you notice now I've stopped putting GCF over here. You can still do that if it helps, but at this point, as soon as I'm creating my GCF, my greatest common factor, I just put it in the question. So I've got a 3, and then I look at the variables. I have x's in both, so that means x will be part of the greatest common factor. And what exponent should that be? Well, I have a 2 and a 1. Pick the lowest, so it's a 1. So it just stays as 3x. And then you kind of break this out. What do we multiply 3x by to get 9x squared? Well, 3 times 3 gives us 9. And x times x gives us x squared. double check. Yeah, that's right. What do I have to multiply 3 by to get 15 for the second term? That would be a plus 5. What do I have to multiply x by to get x? Nothing, just really just 1. So that's done. And then over here, if I'm doing my greatest common factor, I have a 3 and a 5, nothing common there, and I have an x there but not there. So I really have no greatest common factor. But when I do factor by grouping, I always, if there's no common factor in one of the groups, I just put a 1 out front. And I know I told you not to do that earlier, that 1 isn't really a greatest common factor, but for the point of this factor by grouping exercise, it's important, I think, to put the 1, and you'll see in a second. So basically this whole binomial just stays inside the brackets because there was no greatest common factor. 1 times that gives us that. And now you can see, just like the last question, I have a 3x plus 5 that's a common binomial factor of both of these expressions. So that becomes my greatest common factor. Put it in brackets, and then what's left over, if you take that out, we'll have a 3x for this. So the second factor would be 3x, and the second part of that will be plus 1. So you can see I just took the plus 1 from there, and that's why I put it there, so that it would tell me, oh, I have to put a plus 1 there. If I didn't put the 1 there, you might think, oh, there's nothing there, just put a 0. But that would be wrong because you're multiplying. Okay, so that's how you do this. Again, this method might be a standalone question where I give you 4 terms and ask you to factor it, but it's actually a part of another method we're going to learn in a couple lessons from now. So make sure you understand what's going on here and practice the questions which are at the bottom of the page here. Again, factoring, if you want to get good at factoring, you're going to need to know it for grade 11 and 12 and beyond. If you take math or science, you really need to practice. It's not good enough just to look at a piece of paper that somebody else has done. You have to practice to get the hang of it. Okay, so that's it for this lesson. Next lesson, we're going to start a method called simple trinomial factoring. So it's going to be slightly more complicated, but not a whole lot. So, and then there'll be 2 other methods after that, and hopefully you guys will be excellent math factorers. Okay, so have a good rest of the day, and we'll talk to you in the next lesson.